Yeah, hello.
Good evening, sir.
Yeah, good evening. My voice is clear.
Yes, sir.
Okay, nice, nice. So yes, yeah, this is the solve with the session of week 11. So people who have not joined this peer deck, kindly join this. Enter on your browser, either on your phone or laptop, whatever you have. Just enter this joinpd.com. These things. After that, the first thing you have to enter this code LEMETO. So kindly do this. After that, we will start this. So meanwhile, hope all of you have covered the lectures video of the week 11.
Yes, sir.
So is this for everyone? I mean,
Yes, sir, I have.
okay, nice, nice. Then okay. So what is your opinion about the binomial distribution and all this? I mean, level of the things. Is this easy to understand or some
Yes, sir, it's easy than previous weeks.
Yes, sir. It
previous
was easy than previously.
combination, right?
Yes,
Excuse
yes,
me,
sir. It
sir.
was easy.
Excuse me, sir.
Yeah, yes, please.
I have due to some I am attending some other exams as well in my college. So due to this, I have been unable to see all the videos of binomial distribution.
Okay.
So if any question arises, then please please answer them because I may be little bit lacking the
Yeah.
concepts.
Okay. So, I mean, you have watched any single video or even you
I've
did not
just
cover?
watched the introduction video. I just started at 7:30 because tomorrow's the due date to
Okay.
submit the assignment. So
Okay.
I
So just
watched. I will complete it at midnight.
okay. Okay. No issue. Just be with us and just solve all the questions. Try to okay and do that and try to understand. And if still you are facing any problem, then just tell us. Okay. I hope after this session you will be able to solve the questions of binomial distribution. Okay, so there are 23. I mean 21 participants. So there should be 28 students. So people who have not joined till year day, this so kindly enter on your browser joinpd.com. After that, you have to enter this code LEMETO. So please, so that we can start the session as soon as possible. Okay. Okay, let's wait for 1 more minute. After that, we will start. Okay, 13 students have joined. There should be 24. 11 more students would be there. Nice, nice, nice. 16. Okay, so this is the week 11 solid session of the week 11. And people who are not joined ticket, just enter joinpd.com and you have to enter this top right corner code, which is LEMETO. Okay. I hope all of you are able to join this peer deck. How to join? You are able to join this. How to join this peer deck slides, right? So okay, let's move. Okay, so I mean, for every question, according to the level of question, 5 to 10 minutes will be allotted. So keep a pen and paper ready with you so that you can solve the problems and okay. This phase you all are familiar how to enter the answer. Okay, so below corner you will face green things which where you have to enter the answer or select the option, whatever. So okay, should we start? I think right. So let me start. Okay, yeah. So this is something tip to solve the questions. First, I mean, can you tell me how you will identify that this is the binomial experiment? So this is the some criteria. For each trial, you have to identify for each trial. You have to see either it has success or failure, right? Success or failure means the aim of the question, what you wanted to do. Like suppose I'm interested in, suppose I toss a coin 2 times, right? Then I am interested in number of heads. So success will be success probability will be probability for head, that means 1/2. So I mean for each trial. So if you toss a coin 2 times, then for each trial either you will get head or you will get tail, right? That means for each trial, if there is a success and a failure, and you have to also see if the total number of trials is fixed. Like I have tossed a coin 2 times, so 2 is fixed. And you have to also check for each of the trial, I mean is independent and identically distributed. Independent means suppose I toss a coin 1 times, then tossing a coin 1 times is independent of tossing the coin second time, right? So I mean, see here it's mentioned independent trial means that each of the trial is independent of the other trial. Suppose you roll a die 3 times. That means rolling a die first time is independent of the rolling of the second time, and so on. And identical trial means probability of the success is same for each trial. So okay, so probability of success is probability of, suppose for example, getting ahead should be same for each trial. If probability of success is same for each trial, that's the meaning of identical things, right? If any experiment satisfies all the conditions, then it is a binomial experiment. Means it should be for each trial there should be success or failure. Second thing, number of trials should be fixed. Third thing, trials should be independent, and probability of success should be same for each trial. Okay, so till this one it's okay, or I mean, is it clear for everyone?
Yes, sir.
Okay, so this suppose given an experiment, look whether we can classify each trial as success or failure. Also check if trials are independent, identical. If both of these conditions are satisfied, then it is a binomial. Okay, so we are moving to the next slide. Yes, so this is the first question. I think 1 to 2 minutes is more than enough for this question, right? So just read these experiments and select the options which is the correct
Your
one.
voice is breaking.
Sorry,
Sir, your voice is breaking.
is this for everyone or
Yes, sir. Little bit breaking, sir.
okay? I think there might be some network issue. Let me. Now is it okay?
Yes, sir. It is okay.
Yeah, okay. Okay, there should be 29 responses. The people who have not joined this peer deck, just enter on your browser joinpd.com. After that, after entering this joinpd.com, you have to enter this top right corner code, which is LEMETO. Okay, after entering the code, you will be there this on this slide. So please keep in mind all the properties of binomial experiments, in which criteria. Okay, 21 responses. Let's wait for a couple of seconds. After that, we will 22. Yes. Okay, let me log this screen. I think 2 minutes. Okay, let me see the responses. Okay, 13 people are saying option C, 6 people are saying option B, and 4 people are saying option C. The people who have selected option 1 can tell me why option 1 is the correct. Okay, so for third option, why third option is the correct option?
Because sir, every time probability is changing, it's not uniform.
Yes. So see, for the binomial distribution, suppose you tossing an unbiased coin for 100 times, right? So C is the correct option. C is not a binomial experiment because let's take a first example. See, we know each trial should have either success or failure as outcomes, right? Or and should be and should be fixed, and all trials are independent and identical, right? So for the experiment one, we are tossing coin 100 times. So my n is fixed, right? Now, for each trial, for each time we get head, it is success, and if we get tails, it is failure, right? That means for each trial we have two things, either success or failure, right? And since the coin is unbiased, unbiased means fair, means probability of getting head or probability of getting tail is same, that is half. So P is the same for each trial. P will be half for each trial for 100 times. So each trial is independent and identical. That's why it is a binomial experiment, right? Now come to the second. My n is also fixed, which is 100 times, right? But for each trials, we get head, it is success, and we get tails as it is failure. But since coin is biased, biased means we see it is not something fair, means probability of getting head and probability of getting tail is not same. But suppose probability of getting head is C, then probability of getting tails will be 1 minus C, any constant. Suppose probability of getting head is 0.4, then probability of getting tail will be 0.6, right? Hypothetically, let's take example. So, but this probability of getting head C will be same for all the 100 trials, right? I mean, this probability will be same. So this value of probability of getting head or probability of getting tail, which is C and 1 minus C respectively, holds true for all trials, and each trial is independent and identical. So it is a binomial random variable. But come to the third experiment. See, our n is fixed, okay? But for if you see for each trial, we get red ball as success, otherwise it will be failure, right? This criteria is also satisfied. But what's about probability? If you for the first trial, probability of getting red ball will be 20 divided by 40, because if you go in the question, there are 20 yellow balls and 20 red balls, and you have to choose the 5 balls. That means for the first trial you will get 20 by 40, that is half. But for the second trial, probability of red ball will be 19 by 39. That means your probability of drawing a red ball, choosing a red ball, is getting changed for the respective trials, right? That means probability of success is not same here. That's why it is not a binomial experiment. Is it clear for everyone?
So that means probability of success would be same for all time.
Same for each trial. Then it will be binomial.
Okay.
Okay. Is it clear for everyone?
Identical.
Sorry.
Yes, sir, it is clear.
Yeah. Okay. So we can move
If
for
it
the.
is with replacement, then it is binomial.
Yes. Yes.
Yes.
Yes. Yes. Yes. Because suppose in the see, if, okay. Okay. Yeah. This is a very nice point, because if you see in this question, if it's with replacement, then all times probability will be 20 divided by 20 plus 20. Fir,
Same,
for
identical.
the second, it will be 20 divided by 20 plus 20. For the third trial, it will be 20 divided by 20. So probability will be same. So if it's with replacement, then it will be your binomial. Is it clear for everyone?
Sir, in this the thing in the last experiment, it is showing, it is saying that counting the number of red balls. Now counting the red balls can be 0 also, 1, 2, 3, 4, 5. So there are 5 outcomes, na sir? Out of the 5 balls chosen, the red balls can be 0 to 5. So it is not a
Okay.
success or a failure.
Is it not a no?
There
See,
are no
can you
two
tell me?
outcomes. There are
Suppose
6
your
outcomes.
x is follow binomial n comma p, right? Then what x values can take?
X can take
0 till n.
0 to 0, 1, 2, 3,
0,
4,
1, 2.
5.
Okay. So suppose
Yes.
x is a number of red balls, right?
Yes.
So what your x can take? 0, 1, 2, 3, up to 5, 4,
Yes.
5.
Yes.
Okay. That the x values can, suppose x is equal to 0, right?
Yes.
That means probability of no red ball.
Yes.
That means probability of black ball, which will be whatever it will be, right?
Yes.
So x is something, it's about a number of red balls. So see, for the first trial, you can get red ball or not red ball, right? That means
Yes.
that was yellow ball. Suppose for the second draw, again you will get red ball or not red ball.
Yes. Yes. Yes, sir. Yes, sir. Got now.
Okay,
Got it.
that is the something. But for each trial, your probability of success means probability of drawing a red ball is getting changed.
Yes,
Right?
sir. Yes, sir. Yes, sir. Yes,
If
sir.
it's with replacement, then probability will be same. Then it will be binomial. But for this case, it's not a binomial, right? Is it clear now?
Yes, sir.
Okay. So let's move for the some steps to solve the problem for the binomial experiment. Suppose you have to identify the event given in the question. Event means what is your x, what is your p, and all things. Now, suppose I'm interested in like calculate the probability p of the given event, right, of happening. Okay. Then identify the binomial random variable and what is your n? I mean, what is your number of trials, right? Now check is if all the properties of binomial random variable. Check all the what are all the properties of binomial random variable? Anyone?
Should be IID.
One.
Okay,
Yeah.
n should be fixed. First criteria for each trial.
Success or failure.
Success or
failure.
failure, and probability of success should be same for each trial.
Same,
Okay,
same trials.
these
All trials.
are criteria for the binomial random variable. Okay, suppose this after these all properties are satisfied. Okay, after that you have to say like question is said you have to find the probability of x at some value of I. Then you have to apply this formula and choose I p raised to power I 1 minus p raised to power n minus I. I mean you have to apply the binomial formula. Suppose you identified the n, you identified the p, and you know p is same for all the trials, you know n is fixed, then you can directly apply this formula, right? So is this okay?
Yes, sir.
Okay, let's move to the question. So please read the question. I think for this question, I think 5 to 6 minutes will be more than enough. So it's 28 hours, 19 minutes. So I think 8:25 we will see the answers and all. Okay, so please read this and try to apply your concept. Okay, so yeah. Yeah, hello. So hope you are getting the question. So, should I wait? You are trying, or we can move? Because there are only 15 responses out of 20. Okay, so people who are not, I think all of you who joined. Yes. So, okay, so tell me, should I wait or we can move? Because if you are doing, then we can wait for 1 or 2 minutes. After that, we can.
Please move, sir.
Okay, so let me see the responses first from your sides. Okay. Okay, 0.2183, 0.333, 0.0112, 0.1562, 1563. Okay. Means a lot of variations. Okay. Yeah, see. First of all, tell me, you are able to identify this is a what I say. This is a binomial or not?
You said whether it is
Binomial, sir.
Okay, yeah. So suppose see, an archery trainer wants to test the archery skills of newly joined student, okay, which includes some prodigy, skilled or talented. The trainer puts up a circular board of radius 20 meters, right? If the student shoots an arrow in the region of radius 5 meters, then the trial is considered as a success. That means your success is what? If the student shoots an arrow in the region of region of radius 5 meters, right? And whole radius is 20 meters, right? Now,
Yes, sir.
the students undergoes 3 trials. That means your n is your 3, which is fixed, right? Need to get at least 2 successes out of 3 trials to pass the test. Now, suppose prodigy is a student who has very good archery skills when compared to the normal student. Then what is the probability that a normal student will pass the test? That means or also you have to assume for a normal student there is equal chance that arrow will land anywhere on the board. So what you have to find, what probability you have to find? That means probability of x greater or equal to 2. See, okay.
Yes, sir.
Suppose, yes. So suppose this is uh, of 20 circular of 20 meter radius, right?
Radius, yes, sir.
Okay. So and success is, suppose this is your, I'm taking as a
5
5, right?
meter.
So can you tell me so what will be total area?
20.
400
How can you
400 pi.
compute the probability? So probability will be corresponding to the areas, right here. So total area is, you know,
400 pi.
pi r square, that means pi 20 square. Okay, this is the area formula of circle. So it will be 400 pi, right?
Yes.
Now this is the 5, okay, which is your success, right? So success area is what?
25
5
pi.
25 pi. Okay, so what will be the probability of success? 25 pi
25
divided by
by 4.
400 pi.
400.
Yes.
Okay, pi will be, pi will get considered. This is 25 by 400. This is
1 by 16. 1 by
5
1 by
by
16.
200, 1 by 16, right? So 1 by 16 is your success probability. Sorry, yes. So let's move for the solution. Yeah. So this is the, you know, your binomial experiment, as your success probability is fixed, trial number of trials is also fixed. So here I have calculated, you know, area on the circular board which leads to the success is area of, I mean area of 5 pi 5 square, which will be 25 pi, right? And you know value of pi is nothing but 3.142, you know these things. So probability of success will be success area divided by total area of the circular board, so which will be 25 pi divided by 400 pi. So it will be something, what is some total value? So okay, now probability of success we got 0.0625. So probability of failure will be 1 minus 0.0625, right? Which will be 0.9375. So given number of tries is 3, which is in the given question. So let X define a random variable, which is the number of successes you're among the 3 tries. So here, you know what is the formula? Probability of X equal to Y equal to NCI P raised power I 1 minus P raised power N minus N. Now, students should get at least 2 successes out of 3 trials to pass the test, right? So, one second. Yes. Now I think all the things are. So, what will be the probability of passing the test? That means probability of X greater or equal to 2, right?
Yes.
So that means probability of X equal to 2 plus probability of X equal to 3, because X is going up to 3, right? X can take maximum value as 3. Till this equation is clear for everyone, right?
Yes, sir.
Okay. So now, so probability of passing the test will be 3C2 0.0625 square into 0.9375 plus 3C3 0.0625 cube plus into 0.9375 just for 0. So probability of passing the test will be 0.01. I mean this quantity. If you compute the quantity, you will get this value, and you will compute this quantity, you will get this value. So your probability of passing the test is 0.011224, which is
So
1.1.
what percentage are, sir?
No,
What
see,
percentage
it's
are?
in decimal, but you can say 1.12% approximately.
No,
It's
but what was asked in the question, was it percentage or the
in the
probability?
decimal values.
Oh, no, but decimal, okay, but was it percentage or I'm not sure about. So can you go to the question, sir? If it,
Question is about you have to just enter the probability up to 4
probability.
decimal places.
Okay, so
Okay.
not percentage was not asked.
Not percentage. See, if you have probability, then you can convert in percentage, right?
Yes.
Okay.
Yes.
So you got these things. All of you have clear this point.
Yes, sir.
Yes.
Yes, sir.
Okay. So let me move for the next question. Yeah, there is
Sir,
another
there
tip.
is one line. There is. Sir, go to the question, please.
Yeah. Okay.
Sir, what is the meaning of this line? There is equal chance that the arrow will land anywhere on the board.
Okay. That means there is no some biasness, right? See, that means equal chance means if he throw if he what was their question? Yes, if he shoots an arrow, then there is equal chance it can put it can be any of the uh, anywhere of the, I mean, there is equal chance. Equal chance means, so okay, I'm taking the example of toss. Okay, suppose I'm tossing a coin, right? Then there is equal chance of getting head as well as getting tail, right?
Yes, sir.
That is the meaning.
Okay.
Means there is equal chance for, there is not some biasness, right? Suppose in tossing coin you have biasness, then probability of getting or head or something, it will be according to you, some biasness will be there, right? But it's some equal chance. Okay, I mean, hope you are getting my point.
Yes.
So it is basically the equal identical probability of getting the
Identical probability, yes. Okay, there is some
Sir, what
again
is hello?
Mhm.
What
Yeah,
is the
yes.
significance of this classification of tragedy as well as normal person? It does not matter here.
Sorry, what you said? Yeah, prodigy is a student who has very good archery skills when compared to the normal student. What is the probability that a normal student will pass the test? Okay, okay. Yes, yes, yes.
Means
Yeah,
how are
yeah.
we differentiating both of them? Because no
No,
one
it's
gives
something. It's
whether
you
they
can take. You can say it's something extra type of things you can say in the question. Like suppose you as a student, you have a very good archery skills compared to the normal student. Then what is the probability that a normal students will pass the test? It's some, can say some general information. So, and assume for every normal student there is equal chance. I mean, equal chance means suppose you have also good skills, then again the normal students have equal chance for the error will land anywhere.
I think that information is irrelevant to the current question.
Yes, there's something extra.
Sir, if wind speed or something, some deflection is possible, some type of data is given like that, then would the probabilities be changing
See,
or
it's something. So that's why it's writing. There is equal chance, right? Not it's not considering wind and all things. This is something you are going to the physics and all things.
so I
So
don't know anything like that, but in general, they all
no, if
consider
see if
fact.
no if all the things are zero, if all the things are considered, then it will be mentioned, right? Whether we have to consider all the things and or not. Otherwise, it will be clear and cut. Like yeah, probability of getting your success, your aim is this. Like kind of in tossing point half. Previously, it was in the red ball and draw. It was 20 divided by 20. Still it was not same. Suppose with replacement, then it will be 20 divided by 20 plus 20, then your probability of success is half. So I mean it means right with replacement, then I mean all the conditions will be mentioned accordingly. You have to choose your success probability. Are you getting? Then you are considering wind and all things, then it will be mentioned. No worry about that. You no need to think uh, beyond the all the things will be given in the question. Okay.
Sir, can you get back to the previous answer? What was the answer?
Answer was 0.011224. Okay. So there are some steps to solve the question. Again, another type of question. Suppose you have to again. I'm saying identify the binomial random variable. Anybody of you, can you tell me what are the steps for identify the binomial random variable?
First, check independence of the.
First, check for each trial whether you are getting success or failure, right? Your
Yes,
Fixed number
n
of
should be
trials.
fixed. Yeah, and
Fixed
should be
number of trials.
fixed. Yes, and probability of success should be identical.
Same.
Should be same.
Identical.
Okay. Now, suppose in any formula you have to give an expectation of x. You know expectation of x as np. N is the number of trials. P is the probability of success. And variance of a binomial random variable is nothing but np into 1 minus p. Okay, you know where n is the number of trials, p is the probability of success in a trial, q you can interpret as a 1 minus p, which is probability of failure in a trial. Suppose you have given expectation and variance, right? In any question you are given the expectation and variance. You are asking about what are the values of n and p. Then by using these two value, expectation and variance, you can identify the known values of n and p, right? So this is something. Use the expectation formula, use the variance formula. After that you can find the value of n and p, right? Is this clear?
Yes, sir.
Yes, sir.
Yeah, let's move for the related question. So this I think very easy question. I think 4 to 5 minutes will be more than enough. So it's 2038. So we will go for the solution and all things for 20. I think 44. 44 will be okay, or 45.
45.
Okay. Let's do. Okay. So please do that. And people who have not joined this peer deck till yet, kindly enter on your browser joinpt.com. After that, you have to enter this top right corner code LEMETO. Okay. So please join this and solve the question.
Sir, since these are multiplication terms, so can we divide them and obtain the answer?
Sorry, can you
Since
repeat?
they are in multiplication terms, can we divide them and then obtain the answers?
It's see Rohit, please do it on yourself. I mean, you have to apply your thinking how do you compute the compute the values of unknown quantities n and p by given by the given quantities, right? Whether you are subtracting, dividing, and all this. So just a simple mathematical. Okay. And please be focused. Question is, what is the probability of getting 3 tails? Okay. So that means after finding the values of n and p, you have to find the probability of getting 3 tails, right? So please proceed. Okay, then it's 2045. So hope you have. Uh, so let me lock screen and see the responses from your side. So 0.3087, 0.3125, 3087, 3087. Okay, this time I'm saying okay. Majority is with 0.3087. Okay, so let's check what is the solution. Okay, so tossing an experiment is tossing an biased coin. See, please be clear. It should be tossing a biased one. It's not an unbiased one. Okay, so there is a mistake. Yeah, now. So your x is a random binomial random variable that represents the number of tails, right? So here probability of success is what? Getting a tail, right? So it depends on your question type. So your trials, let's say my number of trials is n and success probability is p, and expectation of x is given to me 3.5, variance of x is given to me 1.5. So I can apply the formula of expectation of x, that is which is n into p, which is 3.5, variance of x n into p into 1 minus p equal to 1.05. Then tell me, after this steps, what will be the next step?
So
So,
we need to find value of n.
Okay, you can put it the value of np into variance of x, or you can divide the equations, right? Two equations. So I am divide the equation 2 by equation 1. So I will get 1 minus p as 0.3, right? That means p will be 0.7, right? So after putting the value of p in equation 1, that means in np, you will get value of n, which is 5. It's clear or not?
Clear,
So
sir. Clear.
after
yes, sir, clear.
expectation of np, variance of x is np in and 1 minus p. Suppose this is value a. It was how much?
Uh, 3.5 for
3.5,
NP.
1.05, right? So it's a 3.5, 1.05. So I can put this value in this equation also, right? 3.5, 1 minus p equal to 1.05, because np is the 3.05. So 1 minus p will be 1.05 divided by 3.5. That means it will be what? How much it will come? 0.3, right?
0.7.
0.3.
So p will be 0.7, right? You know
Yes, sir.
np as 3.5, your p is 0.7, then I can put the value in p in this equation, then I will get the value of n, right? So n will be 5,
5.
right? Now your n is 5, you have to find the probability of getting 3 tails in 5 tosses. So what will be? Just a simple formula. ncx, n is 5, x is 3, p raised power x, so p is what? 0.7 raised power 3, 0.1 minus p raised power n minus x, that will be 0.3 square. You will get value 0.3087. Is that clear for everyone?
Yes, sir.
Okay,
Excuse me,
so
sir.
yes, please.
So, what if this question asks like, what is the probability of getting 3 heads? Like it is
Okay.
given, yeah, it is given that variance and expectations of getting a tail,
Tail.
right?
Okay.
What if the question asks, what is the probability of getting 3 heads?
Okay, so tell me here, x is follow your binomial with n comma p. N is 5, p is what? 0.7, right?
7. Yes, sir.
So can you tell me x is what? Number of success?
Yes, sir.
Number of success. Here number of success is what? Number of tails,
Number
right?
of tails.
So you are asking number of heads, right? So if out of n trials, x is number of tails, then can I say n minus x will be
N
number
minus
of
X.
heads,
Yes, sir.
right? Means number of failures
Yes, sir.
for this particular. So n minus will be followed by binomial with n comma 1 minus p.
Yes, sir.
Are you
0.3.
getting?
Yes,
For
sir. Yes,
these
sir. Got it.
things, okay. So just replace the things. Okay.
Yeah, got it, sir. Thank you, sir.
Yeah. Thank you. Okay. Again, if you will be, I think you are worried about how many steps tips are there for. So yeah, this is again something steps to solve the question. So again, identify the event of success and failure, identify the binomial random variable, identify the total number of tries, right? Suppose you are given the probability, means probability of getting I success among n tries, this is given to you, right? Use you have to use the formula and corresponding to value p of x equal to y, you have to find the individual probability, means success probability. So will you able to find? I mean, you have to given n, you have to given this probability x equal to I, then asking about what will be the p success probability, then will you solve it? Are
Yes,
you
sir.
getting my point?
Yes,
What
yes,
I'm
sir. Yes,
trying
sir.
to
Yes,
say
sir.
here? Yeah. Okay. So this is some steps. So this is the next question is based on the previous step. So please read this. I think again, I think 4 to 5 minutes will be more than enough for the question. It's up to you how you are approaching this, approaching the question. So it's 2051. I think 2056 will be more than enough, right? So we will see the solution and of this 2056. Okay. Please proceed. Okay, so if you are trying, so you can wait. So tell me, should I wait or we can move?
Done, sir.
Okay, nice, nice. Okay, let me log. See the responses from your side. 0.4, 0.8704, 0.3478, not 0.4, 0.4, 0.4. Okay, okay. Yeah, let me see the. First, tell me. In the question, it is given that PMF is given to you, right? And X is something random variable which is defined as the number of heads after 4 tosses. So you have to find the probability of getting a head. So here my X is number of heads, right? So it can be 0, 1, 2, 3 up to 4, right? Now we have to ask what is the success probability. PMF is given to us, right? For 0, 1, 2, 3, 4. So this is probability of X equal to X. So what is given for 0? What is the value? 0.1296. Okay. And for the last, it is 0.0256. Okay. So can you tell me how this probability is calculated earlier? For this probability formula, binomial things have been applied, right?
Yes, sir.
Here Q is 1 minus P. So here see, if you see, my binomial formula will have applied here, right? So now question is asking, PMF is given to us. We have asked what is the success probability. Now it's no better idea to start with either first value or last value, because for the first or last value you will get uh, some less quantity. Like for X equal to 0, I can write 4C0, right? P raised power 0, 1 minus P raised power 4 minus 0, which is equal to 0.1296, right? So 4C0 will be what? 1. P raised power something 0 is some raised power 0 is will be 1. So 1 minus P raised power 4 is nothing but 0.1296, right? So here I can write 1 minus P as 0.1296 raised power 1 by 4. So your 1 minus P, how it, what is the quantity?
0.6. 0.6, sir.
Okay, 0.6. Okay.
Yes,
So
sir.
your P will be 1 minus 0.6, which is 0.4.
4.
So see, why I started first with the first value. Suppose you, and let's take for the last value also. That is probability of X equal to 4. That means 4C4, P raised power 4, 1 minus P raised power 4 minus 4, which is 0.025.
0 to 5.
Okay, 0.256. If you see, so if you take the last value and first value, then this two value will be 1, because 4 NCN is 1 and 1 minus P raised power 4 minus 4 will be 0, and something power 0 means 1. So here you will have only P raised power 4, that means 0.0256, right? So P raised power 4 will be 0.0256. That means P will be 0.0256 raised power 1 by 4, which is I think 0.4, right?
Yes, sir.
Okay, so this is the better approach. Suppose you took the probability as X equal to 1, right? Then you will have 4C1, P raised power 1, 1 minus P raised power 3, which suppose what is the value, something whatever. Suppose A is the value, okay? Then you have 4 into P into 1 minus P raised power 3 equal to A. Then you have to multiply these things and it will be complicated things, right? So calculation will be complicated. So in such type of questions where PMF is given to you, you have asked probability of P or Q something, then try to do with the first value or the last value. Is that clear?
Sir, I took a direct, slightly different approach where I calculated
Okay.
expectation, and we know NP is the value of expectation. N is 4, so that's how I
Yes.
calculated P.
Yes. Yeah. That is also nice approach. Okay. See these things I have just explained on the my journal board. So see here, for x p equal to for x equal to 4, 4c4 p raised for 4, 1 is p raised for 0 will be there. So again p is, you will get p raised for 4 as 0.0256. So you can do like p square square. Okay, then you can do. Okay, so here's something. Again it's probability x equal to 0 I can start, which is 0.1296. Then 4c0 p raised for 0, 1 minus p raised for 4, 0.1296 again, which I have explained earlier. So here p is equal to, we get the 0.4. Now come to the expectation. Who has done by the expectation formula?
I have done it, sir.
Okay,
Raghu.
Raghu, that was the very nice approach. Another alternate method is that one, expectation. You are given the PMF value. You know expectation of x is nothing but the summation of I into pxi. That means probability of, you have to do multiplication of values of x into corresponding probabilities, right? So you are given the values of x, you are given the values of p, and expectation of x is nothing but the np. N is given, which is 4. So by the formula of expectation, after finding the value of expectation, you can easily calculate the value of p. Is that clear for everyone?
Yes,
Yes,
sir.
sir.
Okay, so let's move for the next slide. Again something
Sir,
yeah, yes please.
was this PMF, will this PMF be given?
Your voice is some breaking for me.
I'm asking that will this PMF be given in the paper as well?
Yes. Otherwise how will you compute the value of p? Okay, so whether, I mean, what is your objective of the question, accordingly things will be mentioned or given in the will be given in the question. Okay, no need to worry about that. If you're asking about PMF is given, PMF will be given. If it's asking about N and P, then expectation and variance will be given. So accordingly things will be there. Okay. Okay, then again something steps to solve the next question. You have to identify the total number of tries and note down the variance formula, which is nothing but NP into 1 minus P, and use the value of variance and N to solve the unknown values of P. You will you do it or not? I mean, suppose variance of x is given to me, right? N into P into 1 minus P. This value is given to me and N is given to me. Then I can easily calculate the value of P.
Yes, sir.
Okay. The next question is something, this is based on this one. So okay, this is the, I think, so please do it. I think it's 9:04. So I think 9:10 will be more than enough, right? I think it's, yeah, that will, so we'll see in 9:10. Yeah, please do it. Okay, let's wait for 1 more minute because there are only 15 responses from your sides. So please do it. Okay, so let me out the screen, see the responses. 0.4, 0.6, someone has multiplied the values 0.24, 0.6.4. Okay, nice, nice. Okay, someone has entered 4 values. How it is possible? Okay, nice, nice, nice. The first time, kind of, I'm very happy to see after seeing the answers from your sides. Okay, nice. So you are given the variance of binomial and a variable, right? And let me clear it. Okay, so you are given the variance of a binomial random variable for n equal to 8 means 8 trials is 1.92. So you have to find the possible values of p. So if x follows binomial with n comma p, then variance is what? N into p into 1 minus p, which is 1.92 is given in the question, right? Now also we are given that n is 8, right? So I can put 8 in place of n, right? So what I did get here, I will get 1.96 divided by 8. Okay, so what will be this quantity? 1.96 divided by 8.
0.24.
0.24.
Okay, so it's 0.245, right?
No, it's 1.92, not 1.96. It's 1.92,
Oh,
not
sorry.
1.96.
Okay. Yeah, okay. Sorry. So 0.24 is the value for the, I think someone has entered this value directly 0.24. Okay, that is now, see, you are asking about the values of p. So can I do p minus p square?
Yes, sir.
Okay, now again, can I do just do the things on right hand side? So p square minus p plus 0.24 equal to 0. Okay, this is nothing but a solving the quadratic equation. So can I write p square minus I think it will be what 6p, right? No,
Yes, a 0.6p minus 0.4p.
Minus 0.4p.
yes. Yeah, then if you add this quantity you will get minus p and multiplied by, then you will get, I mean, just a properties of quadratic equation. So I can take p as a common, then I will get p minus 0.6, right? Again, if I take 0.4 common from here, then I will get p minus 0.6, right? So I can write p minus 0.4 and p minus 0.6 equal to 0. Okay, so here I will get values p 0.4 or 0.6. So we have two values, I mean 0.4 and 0.6. So which is the correct
Hello, sir.
answer? Yes, please.
Sir, but the between value is minus p and 0.6 minus 0.4 is 0.2.
0.6 or 0.4 is 0.1. I mean 1. I mean, you know the property, I mean, approach how to solve the quadratic equation.
Yes, sir.
Then suppose this is 0.6 minus 0.4. You know, after the factoring, this sum of these two values should be same as this value, right?
Yes, sir.
And then if you add minus 0.6 times p minus 0.4 times p, then what you will get? 0.6, 0.4, you will get minus 1 times p, which is minus p. Is this clear or
Oh, yeah, yes, sir.
not clear?
Or you can go for the usual this thing, right? B square minus 4ac divided by b square minus b plus or minus root of b square minus 4ac divided by 2a.
Yeah, by this formula, minus b plus minus square root of b square minus 4ac divided by 2a.
Yeah.
Okay, you can apply this one. Is that clear? Yeah, this is the something which I have solved. I mean, variance is 1.92. Okay, so n into p1 minus p will be 1 minus 1.92. Just put the value of n, you will get this quantity and this equation. So this is something a general things note for all the values of p equal to c or 1 minus c, we will have same variance. Means if you will put the 0.4, again you will get same values, same variance, and if you will put the 0.6, you will get the same variance. Okay, is that clear?
Yes, sir.
Yes, sir.
Okay. Okay, so that's it for the this week questions. So thank you everyone. So any one of you have any doubt? Anything else?
Yes, sir.
So
Graded assignment 10.
week 10.
Yes.
Okay, Rohit, what is doubt?
Question number 5.
Okay,
Graded
have you
assignment.
gone? Okay, have you gone through the solution PDF?
Yes, sir. But I have, I'm not able to understand how variance is calculated because I applied the formula and got a value close to 3.5, but it is given as 7.46.
Okay, one second. Week 10, question number 5.
Yes.
Okay. Week 10. Okay. So this is the something question number 5. What is the variance distance between the starting point and the end point of the Aman Deep after n steps, right? So what is the formula of variance? Are you able to compute the expectation?
Yes, sir. Expectation has been computed.
Okay. So you know there is formula of variance is nothing but expectation of x square minus expectation of x whole square.
Yes, sir.
So similarly, you can compute for the ith step.
Yes.
Okay, which the things we have did means expectation of xi square will be what? 1 square into probability of xi equal to 1 plus minus 1 square into probability of xi equal to minus 1, right? That means expectation of xi square will be 1 square will be 1. Then probability of p at xi equal to 1 is nothing but the what is given to given in the question. What is the value of p is the given in the question? You need to step to write probability for you, because for everyone
It is given as just 1 minute. I think 0.4.
0.4 is there, right? Then you have to put the 0.4 in place of p plus 1 minus p. That means it will be 0.6. So 1. I mean expectation of xi square you will get as 1 after all. Okay. Now variance of xi, expectation of xi square minus expectation of xi raised to the whole square. So expectation of xi square you will get always 1 for this question.
Yes, it would be 1 because
1
minus 1
minus.
equal to
So
square.
expectation of xi square is what? 2p minus 1 square. Because if you see in the previous exam question, you will get, I mean, you have already calculated the expectation of xi, right? So just put that values and you will get this quantity. And variance of s, nothing but the summation of I is equal to 1 to n variance of xi, because in the question your s is given as summation of xi. Also it is mentioned that about the independence is, I mean independent, about the independency of the random variable, it is already mentioned. So variance of s will be variance of summation I is equal to 1 to xi. Then if all the random variables are independent, then I can write summation I is equal to 1 to n variance of xi. So you have computed already variance of xi. Just put the values of here, you will get your answer. That's it. Is that clear? Okay, it's clear now.
Yes, sir. But can't we do it as 8 square into using the property of variance? 8 square into Vs.
A square.
In my question, 8 steps were given. Means what will be
Okay.
the variance of distance after 8 steps? So there is a property, no? 8 into variance of 8 into s is equal to
See,
8
that is the
square.
something multiplication of suppose okay, your variance of s is something 8 times of x, right? Then
Yes.
you can do 8 square variance of x. Okay, if in the variables some there is some multiplication or any constant, then you can do this. But here what is s? S is summation of I is equal to 1 to n xi. That means summation of n variables, right? Let's take for the 3 variables for simplicity. Okay, then what will the variance of s? Variance of s will be variance of x1 plus x2 plus x3. How can you say this is variance of 3 times of x1? Well, it will be there will be only particular when all the variables are equal. But if there is summation of variables and all the variables are independent, then you have to do variance of x1 plus variance of x2 plus variance of x3, right? This is not variance of x equal to variance of 3 times x. If this is something, then you can do 3 square variance of x. Is this clear now? Yeah. Okay. Anybody else? Anybody have?
Sir, I have a question.
From
Sir,
where? Yeah. Yes. From.
sir, 11.3 activity question.
Okay. 11.3.
Fifth question.
Okay. I think you were in the last session or not?
Sir, I'm not.
Yes. Yes. Because these questions we have discussed, I think, 2 times in the last session. Okay. Just tell what was your approach?
Sir, I'm able to understand this
Sorry.
question. I'm not able to this question, sir.
Okay. See. Suppose that 4.5% of people living in a particular city own a Creta, right? A survey has been conducted to know what brand of cars people use in the city. What is the probability that 12th person being interviewed during the survey is the second one to own a Creta, right? That means
Yes.
if that means there is some first there should be the first person out of 11, because I can make a event a first person from 11 interviewed person, right? Because if you see in the question, it is given that 12th person being interviewed is the second one. That means first person who own a Creta will be out of 11, right? B is
Yes,
the,
sir.
I can make a event B is the second one who own Creta. Second one is who which is 12th interviewed person, right? That is 12th interviewed. I mean, events are not properly defined, but I hope you are able to understand, right? A is the event,
Yes.
something first person is will be out of 11 interviewed person. B is the something which is second. Okay, and you are giving the probability of owning a Creta which is 4.5%. That means 0.045. Now I can define probability of A and B, right? So probability of A into probability of B can I do? Because owning a Creta for a person is independent for owning a Creta for the another person, right? Now for the age, what you have to find the probability for one person out of 11 person. So I can apply binomial. Out of 11 I have to choose one, out of which we have to find the, I mean, 0.045 the probability of owning a Creta. So 0.0545 will rest for 1 into 1 minus 0.045 will be 11 minus 1, that is 10. So this is the quantity for the probability of A. Probability of B will be what? B is something just event, a second one person who own a Creta. Okay. So if the second one person who own a Creta, so for owning a Creta, what is the probability? 0.045, right? So
Right.
for probability of B, it will be 0.045. So this is something. After I mean, you have to calculate this value.
Yeah. Yes, sir.
Okay. So just compute this, you will get your answer. Okay.
Okay, sir. Okay, sir.
Yeah.
Thank you.
Yeah. Okay. Anybody have any doubt or anybody else? Hope got the concepts of binomial random variable and binomial distribution, how to compute the various types of question in binomial random variables. Okay.
Sir.
Yeah. Okay. Okay, then bye everyone. Thank you. Thank you. Thank you very much.
Thank you, sir.
Yeah. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you everyone. Bye. Bye.